Edexcel GCSE, Mathematics Linear, Paper 2, Calculator, Foundation Tier, March 2012. As in any exam, I would take the opportunity at the start of the exam to write down any formula that I think I'm going to need to remember during it. So, as ever, I'm going to write down the area of a triangle is the base times the height divided by 2. I'm also going to write down that there are 360 degrees in a quadrilateral. The volume of a cuboid is the length times the width times the height, and anything else you think might be important to you during the exam. In question 1a, I'm asked to write the number shown here in words, and just by saying that out loud now, or imagining it in the exam, I should be able to solve this one. So 5,076. In part B, I'm asked to write the number 12,507 in figures, and that would be 12,507 without any commas. 1C, I'm asked to write the number 72,879 to the nearest thousand, so I'm going to draw a quick number line with 72,000 on the left hand side and 73,000 on the right hand side, and therefore in the middle I'd have 72,500, and that way I should be able to tell whether my number is nearer to 72,000 or 73,000. Now 72,879 is going to be past halfway, somewhere round about here, so I can see that it is close to 73,000. In part D, I'm asked to write down the value of the 7 in the number 5,709, and again in saying it I've come up with the answer, so I can either write 700 or I can write 700 in words. I need to make sure that I don't just write down this word on its own, as that wouldn't be sufficient. I do need to say that it is 7 hundreds. On question 2, I'm asked to measure the length of the line xy. So I'm going to take my ruler, I'm going to place it on the end at x, and I've got to be accurate here, and I'm going to measure along from 0 until I get to the end of the line at y, and I think that is round about 85 millimeters. Now I could have written 8.5 centimeters, which would have been the same thing, but I need to make sure that I do include my units, as there are 2 marks for this question. In part B, I'm asked what type of angle is angle P, and as that is more than a right angle, but less than a straight line, this makes it an obtuse angle. And then in part C, I'm asked to measure that obtuse angle. So I'm going to place my protractor on the angle so that the crosshairs line up, and I'm going to choose which set of numbers, either the outside or the inside of my protractor, I'm going to use. And to do that, I'm going to locate both zeros and find out which one is actually on the line. This zero here is on the line, this zero here is not part of my angle. So I'm going to count around from 0. So 0, 10, 20, work my way around until I get to 140, and then 150 would be after my angle. So I need to come from the 140 out to the edge, and then count how many smaller 1 degrees I need to get round to my angle. And that looks like another 5 to me. So I've got 140 and then another 5. So I've got an angle of 145 degrees. In question 3, I must complete the table, then write a sensible unit for each measurement. So on the left hand side I've got metric, which will be anything that has in it gram for masses, litres for capacities, or meters for distances. So first part, the weight of a bicycle. Well, the weight of a bicycle is going to be in grams, and as it's quite a heavy object, it's going to be kilograms. Second part, the volume of water in a watering can. Well, that is going to be a capacity, so that's going to be litres. And in part C, I'm asked to write the imperial unit for the length of this page. And the imperial unit for the length of this page would be inches. In question 4, I'm given the colour of a number of cars going past Tom's house in a 10-minute interval. and I'm asked to complete the frequency table. So I'm going to work my way through. So the first one is red, and I'm going to find red, and I'm going to put a tally in the frequency table. And the next one will be blue, therefore 1 in the blue. And I'm going to keep going, crossing them off as I go along to make sure that I don't miss one. Now when I get to this red, that's the 5th of my reds, I'm going to draw a bar across these 4 to give me 5 in total. And then I'm going to continue. So grey, another red, so I'm going to leave a little bit of a space and put the mark for red. And then blue, another blue, and finally a 5th one on the blue there. And then I'm going to complete the frequency column. So I've got 7 reds, 5 blues, 4 whites, and 4 greys. Now I'm just going to check that I haven't missed any. So there were 1, 2, 3, 4, 5 columns, and there were 1, 2, 3, 4 rows. So 5 times 5, 4 would give me 20. So there were 20 pieces of information originally. So if I add these up, I should still get 20. So 7 add 5 is 12, add 4 is 16, add another 4 is 20. So I haven't missed any. Part B, I'm asked to draw the bar chart to show this information, and they've labelled the frequency axis going vertically, and they've labelled the colour of the cars going horizontally, red, blue, white and grey. So all I need to do is transfer this information to the bar chart. So red will be at 7. Now obviously in your exam you would do this with a ruler. Blue would be at 5. White would be at 4. And grey would be at 4 also. In the final part of this question, I'm asked which colour is the mode, and the mode is the most common. So the most common colour of car coming past Tom's house is the one with the highest frequency, and that would be red. Notice I've written down red and not 7, which is the number of red cars. If I'd written 7, that would have been wrong. Question 5a, I'm told that Simon throws a fair coin, and I'm asked to mark on the scale the probability that it will land on tails. Well, when you throw a coin, you've got options of heads or tails, so there are only 2 options, and therefore the chance of it landing on either of them is 1/2, so 1/2. Part 5b, I'm told that Suresh throws an ordinary 6-sided dice, so that would have the numbers 1, 2, all the way up to 6 on it, and I'm asked the probability that she will throw a 7. Now there isn't a 7 here, and therefore that would be impossible, therefore 0 chance. In part 5c, I'm told that there are 3 yellow sweets in a bag, and 1 blue sweet. And I'm asked to work out the probability that a blue sweet will be taken out. Well, I can see that there are 4 sweets in total, so I'm going to split my number line from 0 to 4, which would mean in the middle I would have 2, here I would have 1, and here I would have 3. So the probability of taking a blue sweet, well, there is only 1, so I'm going to line it up with the 1, and therefore the probability is 1/4. On question 6, I'm told that Nathan thinks of a number, he doubles the number, and he adds 5. So he thinks of a number at the start, we'll call that his input, he times it by 2, and then he adds 5, and that gives him his output. I'm told that the answer is 17, so what I'm going to do is I'm going to try and work my way back round from this output of 17. So I'm going to go backwards, so rather than adding 5 here, I'm going to take away 5, and rather than timesing by 2, I'm going to divide by 2, and if I do that in that order, I should get back to my input. So 17, take away 5 would be 12, and 12 divided by 2 would be 6. And I should always check that, so I'm going to start with 6, I'm going to double that number, so 6 times by 2 would be 12, and then I'm going to add 5, so 12 add 5 is 17. So I know I got the correct answer. So the original number was 6. On question 7, I'm given a coordinate grid, and I'm told to write down the coordinates of the point P. This is the point P up here. So I'm going to start at the origin and I'm going to work along the corridor and then up the stairs. So 1, 2, 3, 4 across, so along the corridor 4, and up the stairs 1, 2, 3. And it doesn't hurt to draw arrows on so you can see what you're doing. Similarly, in part 2 of question A, I'm asked to work out the coordinates of R. And again for R, I'm going to go across, so I'm going to go from along the corridor 1, 2, 3, 4, and down the stairs this time 2. So I've got 4, but negative 4 because I've gone left. And similarly, I've got negative 2 because I've gone down. In part B, I'm told that PQRS is a parallelogram. Now I've got PQR, so I just need the point S. And I'm asked to mark it on. So what I'm going to do is I'm actually going to start the shape by joining up R and Q. And then I'm going to join Q to P. And it's now a case of finding out where the missing fourth corner would be. Well, I can see that Q would work across 1, 2 squares. And then to get up to P, I'd have to go 1, 2, 3, 4, 5 up. So if I do the same from point R, I'll get where the point S should be. So 1, 2 across, and then 5 up. 1, 2, 3, 4, 5. And that is where the point S is. And I can just finish that off by actually drawing the shape. And I should see that I get a parallelogram, where these two sides are the same length and parallel, and these two sides are the same length and parallel. On question 8, I'm given 5 shapes, and I'm told that 2 of the shapes have only one line of symmetry. So what I'm trying to do here is split the shapes in half so that the left hand side and the right hand side, or the top and the bottom, are the same. Now I can see that the 2 shapes with one line of symmetry are A, which can be split straight down the middle, and C, which can be split straight down the middle also. So A and C. In part B, I'm told that 2 of the shapes have rotational symmetry of order 2, and that means that when I spin them round through 360 degrees, which is a full turn, they'll look the same twice, and that includes at the end. So to do this, I'm going to trace my shapes. Now in advance, I'm going to trace shape B, and I'm going to mark a arrow on facing straight up, and I'm going to spin that shape round, and I'm going to see how many times it looks the same during that turn. Now I can see that that's once, and if I keep going, that's twice. So definitely B has rotational symmetry of order 2. And the next shape has rotational symmetry of order 2 is shape D. And again, I'm going to mark on straight up, and I'm going to spin that round and see how many times it looks the same during a full 360 degree turn. So there's 1, and there's 2, and the arrow's pointing straight up, so I know I'm back to the beginning. So D would be the second answer. In question 9, I'm told that if you multiply an odd number, so 1, 3, 5, 7, those are the odd numbers to start with, I might have to go on to 9, by 7. So I'm going to multiply these odd numbers by 7. And then take away 2. So I'm going to subtract 2 from those answers. You always get a prime number. And I'm just asked to show that Sherry is wrong. So I'm actually going to do the sum. So 1 times 7 is 7. 3 times 7 is 21. 5 times 7 is 35. 7 times 7 is 49. And 9 times 7 is 63. Now I picked the first few odd numbers as it's unlikely that they're going to ask you to try particularly large numbers, as you could be there for quite a while. And for 2 marks, it's not going to be that complicated. So once I've got my answers multiplied by 7, so this column here in red, and I want to take away 2. So 7 take away 2 would give me 5. 21 take away 2 would give me 19. 35 take away 2 would give me 33, and so on, 47 and 61. And I'm just trying to prove that one of these isn't a prime number. Now I can see that this one here is prime. I can see that this one here is prime. But 33 is not prime. And that's because I can do 33 as 1 times 33 or 3 times 11. And therefore it isn't prime. Now I might want to write some comment along those lines that it doesn't work for 5. Since 5 times 7, take away 2, equals 33, which isn't prime. In question 10, I'm asked to simplify A, add A, add A, add A, which would be 4 lots of A, or 4A. And in part B, I'm asked to simplify 3A, add 5B, take away A, add 2B. And I'm going to group the terms that go together. So 3A and take away A are going to go together as they both involve A. So 3A take away A is 2A, and that's going to form part of my answer. And I've also got add 5B, add another 2B. So I'm going to have add 5B, add another 2B. That's going to be the same as adding on 7B. And I do need that add in there. So it's going to be 2A add 7B. In part C, I'm told that 3x, or 3 lots of x, equals 12. And I'm asked to work out what x is. Well, I know that 3 lots of x is the same as 3 times by x, equal to 12. So I just want to work out what 1 lot of x is. So I'm going to divide both sides by 3. So this would give me x on the left-hand side, and 12 divided by 3 would give me 4. You might be able to work that out straight away, but I just thought I'd go through the explanation to give you an idea of what we were doing. Similarly for part D, y take away 7 equals 5. Hopefully we can spot the answer to it is straight away that y is 12, and the reason for that is that I'm adding 7 to both sides to get rid of the take away 7 on the left-hand side, and that would leave me with y equals 12. In part E, a slightly trickier equation to solve, I've got 2t, which is 2 times t, add 8 equals 3. So the first thing I'm going to get rid of is this add 8. To get rid of that add 8, I'm going to take away 8 from both sides. And if I do that, I'm going to be left with on the left-hand side 2 times by t equals, and 3 take away 8 is going to be negative 5. And now I don't want 2 lots of t, I just want t, so I'm going to get rid of 2 times t. To do that, I'm going to divide by 2. And on the left-hand side, that would leave me with just t, which is what I'm after. And I'm going to have negative 5 divided by 2, and I'm going to write that as negative 5 divided by 2. Now, you might have worked that out as a decimal, which is okay, so 5 divided by 2 is 2.5, and therefore negative 5 divided by 2 would be negative 2.5. Either of those would do as your answer here. In question 11, I'm given the first 7 terms in a number sequence, and I'm asked to write down the next 2 terms in this sequence. So I'm going to try and see what the pattern for the sequence is. So the first number to the second number, I'm adding on 3, and from the second number to the third number, I'm taking away 1. I'm going to see if that repeats throughout the pattern. So 5 add 3 would be 8, so it appears to be working, and 8 take away 1 would appear to be 7, and it is. So I'm just going to carry that on. 3, take away 1. So I need to add on 3. So 9 add 3 would be 12, and that would be my first number. And then I need to take away 1. 12 take away 1 would be 11. And that's my second number in my sequence. In part B of this, I'm told that I've got a different number sequence, and I'm asked to find the 10th term in this number sequence. So to do that, I'm just going to carry this number sequence on, and it goes up each time, adding on 4. So from 21 I need to add on 4 and get 25, and then add another 4 to get 29, and keep going until I get to the 10th term. And just check I've got the 10th term, so the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. That is the 10th term, 41. I'm then asked to write an expression in terms of n for the nth term of this number sequence. Now I can see that this number sequence is going up in 4 from one term to the next, and the only thing that I know that goes up in 4s is the 4 times table. And we can write the 4 times table as 4n, so that's going to be part of my answer. Now if I write out the 4 times table, I can see that it isn't actually at this moment in time equal to this number sequence. However, if I add 1 on to each of these numbers, 4 add 1 is 5, 8 add 1 is 9, 12 add 1 is 13. I am now getting the sequence. So the end term of this number sequence would be the 4 times table with 1 added on. In question 12, I'm told that Mel buys 2 pens costing 55p each. So I need to do 2 multiplied by 55 pence. And as this is a calculator paper, I'm allowed to use my calculator. So 2 times by 55 would equal 110 pence, which would be the same as £1.10. I'm also told she buys 4 pencils costing 28p each. So 4 times by 28 pence. And again on my calculator, 4 times by 28, 112 pence, which is the same as £1.12. And finally, a calculator costing £4.95. If I work out the total of those three, which I can do either by adding, 0 add 2 add 5 is 7, 1 add 1 is 2, plus 9 is 11, 1 add 1 is 2, plus the 4 is 6, plus the 1 would be 7, so £7.17, or I could add up on my calculator, 1.10 add 1.12, add 4.95, £7.17, and then I need to make sure that I answer the question, which is that she pays with a £10 note, and I'm told to work out how much change she should get. So I need to do £10, take away £7.17. And again, I'm going to do this on my calculator, so 10 take away £7.17 is £2.83. Now, always worthwhile when you do a question involving money to make sure that we have got 2 numbers after the decimal point to signify the pence. On question 13, I'm told that P is equal to 2 lots of L add 2 lots of W, and in part A I'm asked to work out the value of P when L is 6 and W is 4. So P is equal to 2L, or 2 times L, plus 2 times W, and this is an L, not a 1. Again, easy to be confused by that. So if L is 6, this is going to be 2 times by 6, added on to 2 times by 4. 2 times by 6 would be 12, 2 times by 4 would be 8, and if I add those two together, I'm going to get a value for P of 20. In part B, I'm asked to work out the value of L when P is 24 and W is 3. So again, I've got my formula, which is P equals 2 times by L plus 2 times by W, and P is 24 this time, so I've got the left hand side of the equation. I know L is what I'm trying to work out, and I need to add on to that 2 lots of 3. So 24 is equal to 2 lots of L plus 6. Now I can either do this by observing or by solving the equation, but I'm going to take away 6 from both sides, and that would show me that 24 take 6 is 18, and this side take away 6 would just be leaving me with 2 times by L. And again, I don't want 2 times by L, I want 1 lot of L, so I'm going to split that in half by dividing by 2 to give me what 1 lot of L is, and 18 divided by 2 would be 9, and that would be my value for L. On question 14, I'm shown a map with some temperatures on it, and in part A, I'm asked to write down the name of the city with the highest temperature. Now I've got 3 negatives, Cardiff at -4, Dublin at -5, and Aberdeen at -9, so it's not one of those, it's either Exeter or London, and I can see that London at 7 degrees is warmer than Exeter at 6 degrees. Part B, I'm asked to write down the name, not the temperature, of the city with the lowest temperature, so it must be either Aberdeen, Dublin or Cardiff, which are my negative temperatures, and I know that -9 is the smallest temperature there, so the answer is Aberdeen. In part C, I'm asked to work out the difference in temperature between Cardiff and Exeter. So Cardiff is -4 and Exeter is 6 degrees, so I'm going to do that with the number line, -4 and 6, and in between -4 and 6, not in the middle, is 0. And I'm going to make the leap from -4 to 0, which is the same as adding on 4, and then I'm going to make the leap from 0 to 6, which is the same as adding on 6. So in total I've added on 4 and then 6, so 10 degrees, and that's the difference between those two temperatures. In part D, I'm told that two cities have a difference in temperature of 4 degrees C, and I'm just asked to write down the name of these cities. Now from the map I can see that Aberdeen is -9 and that Dublin is -5, and that those two are 4 degrees apart. So I'm going to write down Dublin and Aberdeen. And again, if you want to check that, you can draw your number line with -9, -5, mark off the distances in between, -8, -6, -5. I can see that I have jumped 4 in total. In question 15, I'm told that a rugby team played 6 games, and I'm showed the points they scored in each game here. And in the first part, I'm asked to work out the median, which is the number in the middle. So first of all, I'm going to order my values from smallest to largest. So the smallest would be 6. And write that down, crossing them off as I go along. Then 8, then 12, then 18, 19, and finally 24. I'm going to make sure I've still got 6 numbers, 1, 2, 3, 4, 5, 6, as I started with 6 in the first place. And then to find the median, I'm going to work my way in, crossing off one from the smallest and one from the largest, until I get to the middle. Now in this case, I've got 2 numbers in the middle. So I want in the middle of these 2 numbers. Now, I can either do that by looking at it and spotting that there's a difference of 6. So if I half that, I've got a difference of 3, and therefore 12 add 3 would be 15. Or if I'm not sure, to find the middle of those 2 numbers, I can do 12 add 18, which would be 30, and then divide by 2, and that would get me my answer of 15 as well. In part B, I'm asked to work out the mean score for these 6 games. So again, I'm going to go for my ordered list. I'm going to add them all up. And as it's a calculator test, it would make sense to use the calculator. So 6 add 8, add 12, add 18, add 19, 24 is 87. And I'm going to take that number, I'm going to divide by how many there are. So 87 divided by 6 equals, and although I've got it on my calculator, I'll type it in, it's 87 divided by 6 equals 14.5. Now you can do this in one calculation, but you do have to remember to put brackets in the appropriate place. So if I wanted to do this in one calculation, I'll need to open the brackets and do 6 add 8 add 12, add 18, add 19, add 24, and then close the brackets, and then tell my calculator to divide that answer by 6, and that would get me 14.5. If I don't put the brackets in and do 6 add 8, add 12, add 18, add 19, and add 24, and then divide by 6, my calculator is going to take the 24 and divide it by the 6, and then add it on to the other values at the start. And it's going to give me 67. Now hopefully if we get an answer of 67, we should spot that that is not going to be the mean score when all of the scores are less than 24. In part C of this question, I'm told that the rugby team played 1 more game, and the mean score for all 7 games is 16. So I could, if I wanted to, say that in each game, and there were 7, he scored 16 points. And if I added all of those up, I would get 16 times by 7, as the 16 is there 7 times, 112. So I know that the scores should add up to 112. Now I know from part B that the scores actually add up to 87 for the first 6 games. So in the 7th game, whatever they scored would add on to 87 and come to 112. So this question mark here represents the 7th game. So if I can do 112 take away 87, I'll find out what they scored in the 7th game. So 112 take away 87 is 25. So in the 7th game they scored 25 points. In question 16, I'm asked to work out the size of the angle marked X, and I'm given a diagram where I'm shown an angle of 140, the missing angle X, and this symbol here. And I know that this symbol is one that denotes a right angle, and that means 90 degrees. So I also know that there are 360 degrees in any angle at a point. So all I'm asked to do here is add up the 140 and the 90. Should give me 230, and then subtract that from 360. That would be 130 degrees. Now obviously I've done this without a calculator. You could use a calculator if you wanted to. And I'm asked to give a reason for my answer. And the reason for my answer is what I've highlighted up here, which is that there are 360 degrees at a point. On question 17, I'm told that Minnie invested £250 for 3 years at 4% simple interest. So the first thing I'm going to do is I'm going to find 4% of £250. And to do that, I'm going to take 4%, write it as a fraction, which is 4 out of 100, and that as a decimal is going to be 0.04. And again, if you're not sure, I'm simply doing the division of 4 divided by 100, and that's giving me 0.04. And that would be my multiplier. So I'm going to take that multiplier, 0.04, and I'm going to multiply it by the £250. So 0.04 times by 250. And again, I could have used the number that was stored. And that's going to give me that £10 would be my interest for 1 year. Now, as this is simple interest, to work out the total interest for 3 years, I simply need to take the £10 and multiply it by the number of years. So 10 times by 3 would be £30. Now then I'm just going to check what the question is asking me, and it is asking me to work out the total interest, not the amount, so it just wants the interest. So my answer would be £30. In question 18, I'm told that Rosie and Jim are going on holiday to the USA, and that Jim is changing £350 into dollars, and I'm given an exchange rate of £1 is $1.34. So I'm going to write that exchange rate. And I'm going to write my £350 on the correct side underneath the pound. Now what I need to do is figure out how many lots of £1 I'm going to require to get to 350, and that would be 350. So I'm going to multiply the other side by 350 as well, and that will get me that 1.34 times by 350 will be my amount in dollars. So 1.34 times by 350 is 469. So that would be $469. In part B, I'm told that Rosie sees some jeans costing $67 in the United States, and in London the same jeans cost £47.50. I'm told that the exchange rate is still £1 equals $1.34, and I'm asked to work out the difference between the cost of the jeans in the US of A and in London, and I'm asked to give my answer in pounds. So what I need to do is change the $67 into pounds. So I'm going to write my exchange rate of £1 is equal to $1.34 still. And I'm going to try and find out what the exchange rate is in terms of what $1 is worth. And to do that, I'm going to have to divide this number by itself. So I'm going to divide by 1.34, in which case I would divide this side by 1.34. Now if I did that on my calculator, I would get that 1 divided by 1.34 is a rather long number. So I'm not going to write that down. It is 0.746268656, and that is what $1 is worth in pounds. I'm going to leave that there in the calculator's memory, and now I'm going to turn that $1 into $67. And I'm going to do that by multiplying this by 67. Which means I'm going to take this number, I'm going to multiply it by 67, and I've got that number stored on my calculator. So I'm going to times that by 67, and that's going to get me 50. So I now know that the $67 is £50. I'm asked to work out the difference between the cost of the jeans in the USA and in London, so I need to do £50 take away £47.50, and that gets me my answer of £2.50. On question 19, I'm asked to reflect triangle P in the y-axis. So I'm going to mark on the y-axis, which is this line here, and that's where I'm going to reflect my triangle. So if I reflect the triangle, I've got to stay the same distance away from the line. So that's 1 square, 2 squares. So this side is going to be 1, 2 away. So this point is now up here. And if I repeat the process for the other corners of the triangle, similarly 1, 2, so that would be 1, 2 across, I'm going to get where the triangle will now be. And that's where my triangle has been reflected to. In part B, I'm asked to draw an enlargement of the shape Q with scale factor 3. So the first thing I'm going to do is I'm going to go around my shape and I'm going to write the lengths of the side. So 3, 2, 4, and this diagonal length here I'm not going to worry about. Now I want to use a scale factor of 3, so I'm going to take all of these distances and I'm going to multiply them by 3. So 3 times by 3 would be 9, 2 times by 3 would be 6, and 4 times by 3 would be 12. So those are what the lengths of the shape now need to be. So I know that the bottom needs to be 12, so I'm going to mark a space over here where I've got plenty of space to the right of it, and I need to count 12 squares along. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's where the corner of the shape is now going to be. I now need to count up this length here, which has been multiplied by 3, which would now be 6. So 1, 2, 3, 4, 5, 6. And the corner is going to be there. And similarly on the top, it's no longer 3 long, it will be 9 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be my shape. This line here I didn't enlarge, but because I had the vertices of my shape correct, it was simply a matter of joining them up. So my shape will now be this large. On question 20, I'm shown 2 ports at P and Q, and I'm asked to measure the bearing of Q from P. So I'm at the point P, and I want to work out this angle here. So to do that, I'm going to place my protractor at the point P, and I'm going to make sure that the line faces straight up at a bearing of 0, 0, 0 degrees, which is north. And then I'm going to count round, so 0, 10, 20, 30, 40, and I think that's around about 48 degrees. So I'm going to write my answer as 48 degrees. Now, all bearings have got to have 3 figures, so I need to add on a leading 0 to turn that into 0, 4, 8. In part B, I'm told that a rock R is on a bearing of 150 degrees from Q. So I'm going from Q. And I'm told that it is 6 centimeters from Q. So I'm going to take my protractor. So I'm going to take my protractor and place it on Q. And I'm going to measure around 150 degrees. So starting at 0, working my way around to 150 and making a little mark on the dial. I'm then going to draw a line from Q through there that is 6 centimeters long. So from Q through that mark that's 6 centimeters long. That would be point R. On question 21, I'm asked to use my calculator to work out this sum here. So I would advise that unless you're really confident in the use of your calculator, you do this in two separate parts. The first one will be to work out the numerator, which is 2.5 squared, with 3.75 added on, and then that number square rooted. So square root of, and in brackets, 2.5 squared plus 3.75, close the brackets, so it will do everything inside the brackets first, and then it will square root that answer. And I got 3.16227766. And then I'm going to work out the denominator separately, so 3.9 take away 1.7, and that's going to give me 2.2. I then need to take those two numbers and divide them. So now on my calculator I'm going to do 3.16227766, which is why I wrote down the whole number, and I'm going to divide it by 2.2, and it's going to give me 1.437398936. And as I'm told to in the question, I am writing down my full calculator display. In part B, I'm asked to round that correct to 2 decimal places. So I'm going to find the second decimal place, which is the 3, and I'm going to underline the number after it, the 7. The 7 is going to round the 3 up to a 4, so I'm going to have 1.44, correct to 2 decimal places. On question 22, I'm given an equation, x cubed plus 3x equals 41, and I'm told it's got a solution between 3 and 4, which means the answer is somewhere round about 3 and some other numbers. And I'm asked to use try and improvement to find this solution. Now that means I'm going to have to construct a table of values, so I'm going to start with a rough table of values, and on the left hand side, in the first column, I'll have the values I'm going to attempt for x, and in the middle I'm going to have the answers, and on the right hand side I'm going to have a comment. So this is going to be my comment, this is going to be the values I try for x, and this is going to be what I work out as x cubed plus 3x. So I'm going to try 3, and I'm going to do this on my calculator. So I want to do 3 cubed, so I'm going to use the cubed button, and I'm going to add on to that 3 lots of x, so that will be 3 times by my x value, which was 3, and I get 36. So that certainly looks right, that is less than 41. And now I'm going to do the value for 4, so same again, I'm going to do 4 cubed, and I'm going to add on 3 times by 4, my x value is now changed to 4, and I get 76. So the answer 41 is definitely in between these two. So for each of them I'm going to write a comment, that was too small, that was too large. Now looking at these two answers, I can see that 36 is much closer to 41 than 76 would be. So I'm going to try 3.2. So again, 3.2 cubed plus 3 times by 3.2 gives me 42.368. And that, compared to 41, was too large. So I need to look at that, a trial, and improve upon it. So this was too large, so I'm going to try 3.1. So again, 3.1 cubed plus 3 times 3.1. 39.091. And that's too small. So I know that my answer is somewhere in between 3.1 and 3.2. Now, in the original question, it only wants an answer to 1 decimal place. So my answer is going to be either 3.1 or 3.2. Now I know that this one was too large, so my answer is somewhere in that direction, and I know that this one was too small, so my answer is somewhere in that direction. And all I'm trying to do is decide whether my answer is here or here. And to do that, I'm going to go in the middle at 3.15. So 3.15, again on the calculator, 3.15 cubed plus 3 times by 3.15 gives me, and I'm going to write the full display down, 40.705875. And in that instance, that is less than 41, so that is too small. So as this answer was too small, I know that my answer must be somewhere above 3.15. And from that, I can see that my answer is somewhere in this area here. And anywhere in this area here is going to be closer to 3.2. So my answer for x would be 3.2. On question 23, I'm given a right-angled triangle, my right angle here, and I'm given a couple of distances in it, which is 8 centimeters here and 16 centimeters here for the longest side. So that's the longest side. I would say that this is the shortest side, and I'm going to call this the medium side. Now I know that some people sometimes refer to these as different letters. This is called A, this is called B, and this is called C. I'm going to use short, medium, and long. I'm asked to calculate the length of Q to R, so in my case that is the medium side, and I'm told to give my answer correct to 2 decimal places. Well, this is a question concerning Pythagoras, so first thing I'm going to write down my version of Pythagoras, which is short squared plus the medium squared equals the long squared. And the short side in this instance will be 8, and I want to square it. The medium side is what I'm trying to find out, so that would be left as medium squared, and the long side is 16 squared. So I'm going to do those sums on my calculator. So 8 squared, again using the squared button, is 64. And 16 squared will be equal to 256. Now I'm trying to work out what this is here, the medium squared, so I need to isolate that and get it on its own. So 64 add this number is 256. So if I subtract 64 off this number and off this side, I'm going to get what m squared would be. So m squared is going to be 256, take away 64. So again, it's there, but I am going to type it in again. 256, take away 64. 192. Now that's m squared. I want to know what m is, so I'm going to have to undo the squaring, which is done by using the square root function. And I'm going to square root 192, and that will give me what m is. So the square root of 192 is equal to 13.856406646. And I'm asked to write that number to 2 decimal places. So I'm going to find the second decimal place, which is 1, 2, so the 5 here. Underline the 6, and that's past halfway, so the 5 is going to go up to a 6. So my answer to 2 decimal places will be 13.86. In question 24, I'm told that Ricky has a packet of flower seeds, and the table shows the probability. Now I know that all the probabilities, because these events are mutually exclusive, can't happen at the same time, should add up to 1. So all I need to do is add up these 4 numbers and find the difference from 1 to work out what the probability of it being white will be. So I need to do 0.15, add 0.25, add 0.20, add 0.16, and again I'll do that on my calculator. So 0.15, add 0.25, add 0.20, add 0.16. And that gives me 0.76. And I need to take that answer away from 1 to work out the probability for white. So 1 take away 0.76 is 0.24. So the probability of white is 0.24. In part B, I'm asked to work out an estimate for the number of red flowers if there are 300 seeds in the packet. A couple of ways of doing this. First off, the probability of red is 0.25. And as a fraction, that would be 25 out of 100. Now I know there's 300, so I'm going to try and make this out of 300. And to do that, I'm going to multiply by 3. So if I multiply the numerator by 3 as well, 25 times 3 is 75. The other approach, somewhat more simple, is to take the 300 seeds and multiply the probability 0.25. And again, if I did that on my calculator, I'm going to get my answer of 300 times 0.25, which is 75. On question 25, I'm told that Caleb measured the heights of 30 plants, and that information is summarised in the table. So I've got 2 plants that have got a height of between 0 and 10 centimetres, further 8 plants with a height of between 10 and 20 centimetres. And if I add this column up, I'm going to get the 30 plants that I'm told about in the question up here. So the first thing I need to do is come up with an estimate for the height of these 2 plants that are between 0 and 10. And to do that, I'm going to add 0 and 10 up, and then I'm going to divide by 2. So 0 and 10 added together will be 10, divided by 2 will be 5. So an estimate for the height of these plants will be 5 centimetres, and this column is called the midpoint. Now obviously if you don't have to add them up to find the midpoint, you can do it without. So I know the midpoint of 10 and 20 is 15. Okay, again, if you weren't sure, you can add up the 10 and the 20 and then divide by 2, and that would give me 15. And I'm going to keep going down, 25, 35, 45. Okay, now I've got 2 plants with a height of 5 centimetres, so in total they would have a height of 2 times by 5, which is 10. And I've got 8 plants with a height of 15 centimetres, so I'm going to work out what they would be using the same method of multiplying. And I'm going to do that down here because I'm a bit pressed for space above. So 8 times 15 is 120. And then I've got 9 times by 25. $225, and 7 times by 35, $245, and I'm going to continue until I've finished with all the numbers in my table. 4 times by 45 is 180. Okay, if I transfer those numbers to my table, 120, 225, 245, and 180. Now I know that the mean is add them all up, divide by how many there are. So I'm going to add them all up here. So 10, add 120, add 225, add 245, add 180, and I get 780. So the list adds up to 780, and I'm told in the question that there are 30 plants, or I can see that from my table. So I need to do 780 divided by 30, which is 26. So the mean height of the plants estimated would be 26 centimetres. That concludes the exam paper.